All right, so welcome back to Computer Science E1. My name is David Malin. I'll be with you again here this evening. So next week won't be so much of a lecture as there will be a movie night. So we'll be showing you the first of two films in the course, both of which we think are great fun. The first one is called Pirates of Silicon Valley, and this is a dramatization of really the rise of both Microsoft and of Apple back in the day, led by Steve Jobs and by Bill Gates. And you'll find that it's a fun way to kick back and actually get a sense historically of how really these computers we now take for granted on our desks, and now more recently these devices in our pockets, really started to gain traction not all that long ago. So we'll order in some snacks, some candy and the like. You're welcome to bring family and friends and dates and whatnot. We'll dim the lights and roll film next week. Same time, same place. And then we'll return the week after with a more in-depth look with Dan at the helm at the internet and how that all works. So any questions about hardware or things we began to look at last week? Anything at all? Now, all right, so let's try to motivate tonight, where we'll look in a little more detail at all things hardware, but particularly at a higher level. So last week, we kind of started at a pretty low level to the point of actually doing math on the board and using bits and talking about binary system. And that's hopefully interesting or enlightening, but not something that you're going to be using on a daily basis, but that henceforth we can take for granted. That at the end of the day, everything we do on our computers, everything we do in this course really does reduce to those zeros and ones, but we can begin to layer on top of all of these fundamentals. And we'll see the same pattern actually when we talk about the internet. It turns out that it took many years for us to get to this point of just double clicking and all of a sudden you're checking your email and you're on Facebook or the like. There's many different technical layers underlying that we'll look at in more detail. But again, once we've done that, we can then take for granted some of these lower level building blocks. And so tonight, let's motivate the discussion by taking a very real world look at, say, one website, one of two websites perhaps, one for Mac users, one for PC users. And I'm going to go, for instance, to apple.com as a starting point. Now, just to get a quick sample of folks in the room tonight, how many of you on a daily basis use a Mac, would you say? Okay, so feels like just over half. And how about PCs, just so I can measure the... Oh, okay, about the same number, give or take. Okay, so some of you, I think, are using two computers, which is skewing the numbers. But it feels like it's a rough, maybe 50-50, give or take. And what's striking, frankly, is that the Macs have certainly been on the rise over recent years, at least in academia. There's long been this bias. What you'll find, though, is that so far as this course is concerned, it doesn't really matter to us on a conversational basis what computer you're using, because at the end of the day, they really are pretty fundamentally the same. It's just these different companies. Apple and Microsoft had made different decisions when it comes to what software to give you out of the box, what the software looks like, where your menus are, but you'll see that the fundamentals really are the same. And in fact, it's kind of funny sometimes if you take a look at these things side by side. Those of you with Windows know that the Start menu tends to be at the bottom left-hand corner. Those of you with Macs know that the Apple menu is at the top left corner for no compelling reason to be different. If you want to close a window on Windows, you click in which corner of the window? Top right, but on a Mac, you click in the... I mean, it's as though these companies were just being different for the sake of being different. But once you get past, frankly, some of these differences, especially if you're among those less comfortable with computers and, even the slightest difference versus your home computer, your work computer, kind of throws you, at least at first, realize that a lot of these differences are pretty stupid and pretty meaningless. And once you realize that, you just have to find your way around for the first time, you'll start to feel quite at home. So let's do this as though we wanted to shop for a new computer. Specifically, let's say a laptop initially, because these things are all the more in vogue these days. And let's see what kinds of buzzwords or numbers or units of measure jump out at us, and then see if we can't tease these apart. So what Apple sells for our purposes doesn't so much matter, but you can kind of see in the middle there that they sell desktop computers, laptop computers, and then these newfangled mobile computers at the top. But let's go slightly more traditional at the laptop line. I'll zoom in here, and to be honest, and realize that this story should hopefully apply even if you're not necessarily in the market for a Mac. We can do the same story in just a bit on the PC side with an arbitrary PC vendor. So it looks like there's at least three starting points here, a so-called MacBook, MacBook Pro, MacBook Air. And what's the only difference apparently at this point in the story among these three models? All right, so size, it seems, just proportionally looking at the pictures there. And then also price. Feels like MacBook Pro is at least going to start at $200 more than the other, so maybe it does actually some more for me. So let's take a look. I'm not feeling particularly ambitious in terms of price. MacBook Air, I've heard good things. I saw that advertisement just a moment ago, so let's click through on this and see what kinds of questions we get asked and see if we can't now begin to assemble some technical yet some down-to-earth answers to those questions. So apologies for the little flickering here. This has to do with the refresh rate, so only look at the screen 85 times per second and your eyes will be synced. So here we have two different models. The left-hand side is 11-inch, the right-hand side is 13-inch. So what's the relevance here? Well, one of the details that's worth noting here is there's a sort of buyer beware. Anytime you buy computer laptops or computer displays, for a long time, the industry got away with calling a 21-inch monitor really a 20-inch monitor with 1 inch of plastic around the outside of it. And so there's these little issues that if you really care about this level of detail, if you're a graphic artist or the like, you should at least be mindful of, or you should at least realize that you shouldn't necessarily take all of these numbers at face value. There's case in point, last week we talked about USB sticks, the sort of flash memory you can carry around on your keychain, and how you plug that 1 gigabyte stick of memory into your computer, and you only seem to see 900 megabytes. You seem to be missing 100 megabytes. Well, that's because what someone calls 1,000, someone else might call 1,024. Recall our discussion of what a kilo is interpreted to be, and those slight differences do add up over time. So again, just beware of some of the literature, though thankfully these days there's not a huge difference between 900 megabytes and 1 gigabyte, but if you're trying to actually fit some known piece of data, you might want to be cognizant of this. Now, what's the difference really here? Well, there's clearly a price difference. On the left-hand side, we've got $999. On the right-hand side, we've got $1,599. So what really are the differences you might, as a consumer, actually feel compelled to care about? And the unfortunate thing, frankly, in this market, not just with Apple, is that you'll find that it's very easy, frankly, to get upsold, just another $50 or another $100, because it's like, $50, I can get 200 more megahertz, 200 million more things could happen in my computer per second. I feel like spending the $50. But then you hit this other price point. It's like, well, for another $50, I could get another 100 megahertz, and another $50, I could get a little more RAM. And so you'll find, frankly, that the marketers have very carefully chosen these price points, where in between two price points, it rarely feels like a big deal, but very quickly is it a slippery slope where you find that, well, okay, why is my computer now $1,599? So let's try to ask ourselves, what things should you actually care about? And to real-world users, what are the numbers, what are the costs that actually might make you feel a difference when you're actually at home with these things? So let's start cheap. Let's go all the way on, let's say, the left-hand side. It's worth noting that 11-inch computer is what's generally called a netbook these days. Frankly, this is just a stupid piece of jargon to describe a laptop that's smaller than most laptops. It doesn't represent really any fundamentally new technology, but a netbook, small laptop, has Wi-Fi support, wireless internet connectivity. We'll talk more about that in a couple of weeks. That doesn't mean you turn it on and you have internet access. It means you still need to be in range within like a Starbucks access point or a home router. Again, some things we'll talk about in a couple of weeks' time. But the marketers out there realize that there's kind of this opportunity where everyone wants to use a laptop these days for checking their email and getting on the web, but they want portability. So let's shrink this stuff down. Let's make sure it has the basics, like enough RAM to browse the web and check your mail and internet access, but maybe it doesn't have like a traditional printer port anymore or some other ports, connectors that you might not necessarily need with as high frequency. And so thus were born netbooks. And that's what this 11-inch MacBook Air happens to be. So let's focus on some of the technical particulars and then tease those apart over time. Frankly, if you're in the market for a computer, one of the upsides of Apple's lines is that, frankly, they tend to make things a little simpler overall. Even though they, like most people, would love for you to go up and up and up on the price scale, they tend to give you fewer options than some manufacturers, which for the true geek might be a downside if you don't have that much control over your computer. But frankly, for someone who just wants to get real work done, being offered the equivalent of good, better, best is a pretty compelling story. But which of those should you actually be paying for? Well, the first choice we get to make here is in terms of memory. So there's some scary looking numbers here at first glance, but really right now there's only one you should probably care about. So these two radio buttons, as they're called, the little mutually exclusive circles, we'll learn about those, how to make those when we get to HTML later in the semester. But what do you think are the two numbers you should care about here between the first one and the second option? Yeah?
2 gigs versus 4.
Yeah, it's like, I might not know what the heck the rest of the Greek is after those numbers, but there's clearly a numeric difference that I can appreciate. 2 GB for gigabytes. We talked about that last week, versus 4 gigabytes. Now, what do the other numbers actually mean? Well, 1066 megahertz refers to the speed of the RAM, just how quickly it can do its thinking, how quickly electricity can flow through this device. Generally speaking, more megahertz, the better it is, the more it's going to perform. But it's kind of irrelevant, at least to us right now. And why might I propose that it's irrelevant how fast this RAM is? Yeah, it's the same for both of these options. So if I've decided physically I like the look, the sexiness of this particular 11-inch computer monitor, this particular laptop model, well, it doesn't really matter at this point in the story what the speed of the RAM is, because you only have the choice of quantity, not necessarily quality here. The mention of DDR3, this just refers to the technology in use. So RAM has evolved, like most parts inside of a computer over time. There was DDR2, there were precursors to that. So DDR3 is one of the newest versions, so to speak, of a type of hardware known as RAM. And RAM, recall from last week, is that volatile storage. It's where your programs are running when you double-click an icon and you're actually using them. And this is in contrast with your hard drive, which is where stuff gets saved long-term, when you pull the power cord, when you shut down for the night, and so forth. So is it worth it? Those just based on instinct, based on past purchases. Do you want to double your RAM for $100? It's kind of game show style. What do you think? Thoughts? What's that? Cheaper on Newegg. Okay, cheaper on Newegg. Okay, so that's actually an interesting side. If you're feeling a little more adventurous, or at least you have a buddy who might be willing to start unscrewing things from the computer, buying third-party hardware is sometimes very much an option, whereby you go on some website. You mentioned Newegg.com, Newegg, which is a very popular geek-oriented hardware site where you tend to get pretty good prices. You can buy compatible RAM, unscrew the requisite parts of the computer, plug it in yourself, and voila, you've saved yourself some money. This is particularly true for Apple. Frankly, almost any time you opt for more RAM or more disk or more anything, they're really marking types of memory up in particular. Now, with that said, older Mac models were actually harder to open up and to actually install this stuff. But if you do some sanity checks online by Googling around, looking for the user's manual online as like a PDF, you can get a quick sense of whether or not this is going to involve removing one screw and one piece of plastic or metal, or if I actually need to lift the keyboard out and have a authorized technician do this. But again, this is one of those things. Don't necessarily rush out and start taking apart your laptops tonight, because there are cases where, depending on the model, you'll void your warranty if you break a seal or break some sticker. So just beware. But it depends really on what you're motivated more by, sort of that comfort of the support contract versus the price point, or really anything along those lines. But this upgrade between 2 gigs and 4 gigs, whether you buy it from Apple or you go third party, frankly, it's pretty compelling. If you're already spending $1,000, spending $100 more, I would argue, or even slightly less than that, to double your RAM, that's actually pretty compelling these days. So more RAM is useful for what possible reasons? Think back to last week.
You can be running a lot of programs.
Yeah, so you can be running a lot of programs and yeah, so running programs simultaneously. If you want to run Microsoft Word and say Safari or Firefox or your instant messaging program, the more RAM you have, the more of those programs, the more zeros and ones can fit inside of your computer's RAM at a given time. And the upside of that is that they don't need to be, quote unquote, swapped to disk. They don't need to be moved into what we called last week virtual memory. Recall that virtual memory is this illusion that a computer can give whereby hard disk space is used as though it were RAM, and virtual memory is used really when your RAM gets filled. And the computer doesn't want to say to you obnoxiously, you're running too many things. I'm not going to let you run this additional program. These days, computers try to be flexible. They'll let you run that program, but they'll secretly move some running program to the hard disks temporarily. But you're going to start to feel that difference, because hard disks tend to have, as we'll see today, moving parts. And anything that has moving parts tends to be slower than something purely electrical, like a piece of RAM, which we'll also look at physically today. So virtual memory, good in that it lets you run more things, bad in that it starts to slow things down. You try changing windows and the experience feels like it's starting to get to a crawl on your computer. So in general, more RAM is actually not a bad thing. It's one of those things that's probably worth the upsell whether it's comes with the machine or you buy it somewhere else. SuperDrive, some of the stuff is fluffy and probably not all that interesting, but worth being mindful of. If you're coming from the world where you've had a CD or DVD drive built into your computer, well, one of the reasons that 11-inch computer is small is that it doesn't have said drive anymore. Now, frankly, these days, it's rarer that you actually need to have a so-called optical drive, a CD-ROM or a DVD-ROM drive inside your computer. Because one, people are using flash memory more, USB sticks and those kinds of things. Two, people are downloading software more often than they are necessarily installing it from a CD. And just think to yourself, and maybe you're an exception to the current rule, but like when was the last time you used a CD in your computer? Like anyone this week, maybe? It's okay if it was. Okay, so 4 of you. Anyone past? What's that? No. Okay, so that's 1 fewer. So good. That's reinforcing my point. Oh, but 1 more. Okay. Okay, so not as many as it might have been, say, in yesteryear, but that's really a judgment call on your part. So let's fast forward to some of the other potential details here. A display. While I'm buying a laptop, I'm not sure I want to buy a LED display, a monitor for another $999. Documentation, seems I have to get it in a particular language. But then these things too. One of these reasons these small laptops, these netbooks are so small is they don't have an Ethernet jack anymore. Now in your home, maybe you're using wireless these days, so this is not a big deal. But if you prefer to use wired because of the speed, the security potentially, more on that later in the semester, or at work, if you have to use a physical cable, we're going to need one of these silly dongles. A dongle is just a little short cable that's got one type of plug on one end, the different type of plug, generally bigger, on the other end. The idea being that this is how you give a small device a bigger port. You attach this additional dongle, so to speak, to it. So this might be a downside. And frankly, on Apple's site, the rest of the choices you have relate only to software, which isn't so much of interest just now. Now, if we scroll back, let's just take a moment back. This was the MacBook Air. This is the thing that tends to look fairly sleek and sexy. The MacBook Pro, in Apple's world, tends to be more of the workhorse. And here's where we can see some more interesting, some harder numbers to ponder. So there's a lot on the screen at the moment, but consider this, and Apple actually guides you pretty much toward a good methodology for making a decision. What should be the first question you answer for yourself when buying a new, let's say, laptop? I mean, in the real world, if you were buying a laptop, what would you hope the salesperson would ask you first? Or how would you like to narrow it down? Sorry? All right, so what are you using it for? So if your needs are something like word processing or Excel or email, web, that's actually a good thing because there's really not all that many constraints on you. Now, one of the first constraints, though, might be how much time of the day you're going to be using this thing. Frankly, for reasons of like repetitive stress injuries or just comfort, ergonomics, you might actually want a desktop model. For now, let's assume we want laptop for portability. And so once we've decided that you don't have particularly special needs, and therefore you don't need to be upsold to like the $2,000 model, what might the next reasonable question be? Yeah, so what size? And this is why I say Apple's actually pretty good at laying out the options because, frankly, for a real-world user, especially for a laptop, you probably care a decent amount about the size and the weight. If you're going to be lugging this thing around, you don't want it to necessarily be a 9-pound device, even though it might be super fast. You might really prefer that it be 2 pounds and just 11 inches in its diagonal. So Apple kind of lays it out here. 13-inch, 15-inch, and then there's 17-inch. If we roll over to the right, how to decide. Frankly, go to a store, look at a friend's computer, and just get a sense for yourself, I would recommend, as to what size laptop you're looking for. And there really is a difference. Like this thing that I'm using here tonight, this is happens to be the 15-inch model. And it's reasonably heavy. I think this thing is 6 pounds, 6 pounds, somewhere in that range. Whereas the MacBook Air, I think is literally, certainly the 11-inch, is less than 2 pounds, which is pretty darn light. But the downside is, 11-inch screen means like if your eyes are aging or it's dark or you just are sitting a couple feet away, frankly, it's not necessarily going to be the most pleasurable experience. So just in terms of your experience, that might dictate which direction you go off in. All right, so collaborative. What size screen do we want to go with? 13-inch, which is pretty small, 17-inch, which is pretty big, or 15-inch, which you can get a quick sense of there. I'm not trying to guide us toward any answer. I actually don't care. Although I could hear myself about to say just right. 15-inch. All right, so let's split the difference, 15-inch. Now, I should say there are some dependencies, and these are details that fundamentally aren't important today, but one of the decisions Apple made for reasons of size, weight, heat, performance, somewhat technical reasons, it turns out that the speed of the computer will in fact be influenced by this first decision of ours. The reason, frankly, that I chose this model instead of the 13-inch, whose weight I actually prefer, is that I was able to get a notably faster CPU in the 15-inch model. It did cost a bit more, but this was a trade-off. Sort of imperfect world, I wanted 13-inch, but I wanted fast, couldn't have both. And so I needed to compromise, and so I went with another pound or two to get that performance. So let's choose 15-inch. Looks like we have 3 different starting points, which can start feeling a little overwhelming. And unfortunately here too, the price points aren't all that different. So there's a pretty big difference between $17.99 and $21.99. But then there's one that's $19.99. I feel like if I'm already going to be spending like $2,000, it's not necessarily a huge difference. So here's where it gets a little tricky. So on the left-hand side, time to get overwhelmed. We have, for this model, a 2.4 gigahertz CPU. Looks like it goes up to 2.53, 2.66, right? It doesn't feel like big jumps unless you start comparing the extremes. This one has what's called Intel Core i5. What the heck is an i5? Yeah, so it's a processor. You might not know this. Frankly, a quick Google search will give you some keywords most likely, and i5 will be associated in most any search engine with the notion of a CPU, a processor, the brains of the computer. And so we recall we saw gigahertz last week, and this is just how many billions of things can this computer do per second. Billions of things at the very low level, addition, subtraction, but generally more is better. But with that said, you know, who did we say was sort of the slowest piece of the puzzle last week when sending an email, for instance, or just browsing the web? Was it the network? Was it the CPU? Was it the RAM? Was it the operator, right? The human, right? The reality is that for a lot of computer uses, all of us are the weakest link, frankly, in the puzzle. We're the slowest device that's interacting with this other device. And so, you know, you might churn through 100 or so emails a day, but are you really going to appreciate the difference between 2.4 billion somethings happening inside that machine versus 2.66 billion somethings happening per second? Most likely not. Now, by contrast to your suggestion earlier, consider what your usage is. If you're trying to direct and produce a movie using iMovie or some homegrown video software, if you really like doing graphics with a program called Photoshop, and then here you might actually really need to tax your processor. It's got to do a lot of math to render all these colors and pictures and let's say animations. Well, in that case, you might benefit from the faster CPU. But again, for normal usage, let's say, starting at the low end is quite reasonable. So what else? 4 gigabyte memory. What kind of memory, though? Yeah, so Apple's kind of dumbing it down here, maybe in a reasonable way, but that's RAM. That's not hard disk, that's RAM. And you can infer that by the fact that, frankly, it's relatively low. Last week, we arbitrarily said that RAM tends to be single digits gigabytes, whereas hard disk space is generally triple digits. But that heuristic will change over time. This is pretty explicit. 320 gigabyte hard drive. SD card slot, what's that? What's an SD? Yeah, those little memory cards. If you've got a digital camera, unfortunately, the market has so many darn types of digital memory these days. Not all of them are compatible. Well, SD is one of them. So this means this laptop actually can let you take that little memory card from your digital camera or similar device, plug it into the Mac, and it will just mount on it will just appear as an icon on your desktop. You don't need an adapter or anything like that. So maybe that's compelling, but it's only one type. So beware being told by the salesperson, oh, you can use your digital media card in here. Well, what kind? SD is the type. There's compact flash, CF. There's SDHC. There's 7 or 10 more that are still in vogue today. And in fact, if any of you have a monitor or one of these memory card readers, frankly, they're ridiculous looking. They generally have 3 or 4 or 7 different slots, all of different sizes, just to be as universally compatible as possible. And this is just because all these different vendors just weren't really agreeing on any one standard. All right, but maybe that's useful if you're a photograph aficionado. Built-in battery, so what's to be 8 to 9 hours? That's pretty darn long, right? You can fly across the country, you can get a little bit of a layover out of this thing, but what should you maybe be mindful of here? What's that? Okay, so weight is definitely a concern, and it's kind of curious that Apple's not telling us the weight here. So let's see if we can dive a bit deeper and figure that out in a moment. But in general, about battery life.
It varies.
It kind of varies, frankly. And 8 to 9 hours on one charge, I don't think I've ever had a computer, and I have that computer, get that many hours of actual usage. So beware here. Anytime someone quotes you a battery estimate, frankly, and this is not scientific, but just based on sort of real-world experience, dividing it by 2 is not an unreasonable rule of thumb to say that you're more likely to get 4 to 4.5 hours. Frankly, that feels a bit more realistic. And I can say this having my computer die in the middle of a flight to California. So I have at least one data point for this.
You're using Forks my iPhone when I view the videos.
Mm-hmm.
The battery goes much quicker.
So that's very true, and that's the thing. When I'm flying across the country, I'm often passing the time by watching some stupid movie or the like. And if I have all of the sound and these moving pictures on my computer, that actually is going to consume more battery life. Just like watching an academic video, even on an iPhone or similar, is going to consume more battery life. If you've got your brightness all the way up, if you're listening to your music through your headphones on the laptop, that's going to be requiring more battery life. If you're actually doing all of your Photoshop work or rendering, that is producing your video on the computer, anything that's going to make the CPU actually start to heat up and do more thinking, do more math, is going to end up costing you more energy and therefore decreasing the battery life. So you have to beware. Like anytime a company, whether it's Apple or someone else, comes up with a measurement of how long the battery lasts, most likely that computer was sitting in a nicely chilled room with the brightness not all of the way up, maybe running a program, but not actually producing a movie or something like that. So again, another heuristic you can use, or another tool you can use here is, frankly, Google is your friend. And there's reviews. There's computer magazines, Mac magazines, PC magazines, where real people have actually run Photoshop or run some fancy game or have checked their email on this computer for many hours, and then they report in Consumer Reports or the like exactly how many hours you should expect in the real world. So you can do some sanity checks there. And this might matter. Frankly, if you're a business person who does commute back and forth, if your computer's dying consistently, maybe you should have gotten the model with the bigger battery. But don't believe everything that you necessarily read. How about some other numbers here? So Intel HD graphics, that's pretty meaningless, frankly, here. There's no choice, and that's not even a model number, so I'm going to breeze past that. But specifically, there's this, NVIDIA GeForce GT 330M with 256 megabytes of something. So what's the takeaway here? So one, this is mostly branding and marketing here. This isn't a lot of technical words. NVIDIA is a graphics company. Turns out that computers are doing such increasingly fancy things these days, from graphics to movie capabilities and the like, that you don't just have one brain in a computer, you kind of have at least 2 brains. One of them being the graphics brain, the graphics processor, or GPU, as it's often called, in contrast with the CPU. And these graphics cards or graphics processors tend to come with their own memory, their own RAM, pretty much so that you can reserve your actual CPU and your actual RAM for sort of normal programs, but anything graphical gets offloaded to this other hardware. So who might this affect? Well, what kind of users might actually care what kind of graphics card and how much graphics memory there is in a computer? Yeah? Yeah, a game player, to be honest, right? If you've ever used, or yourself, or you've watched really avid gamers with their headphones on and their huge monitors and their fancy joysticks and whatnot, I mean, one of the biggest or most expensive parts of that picture generally is the computer itself and also the graphics card inside. You can get a dedicated graphics card for as few as a few $20 or so. Or you can spend $500 on the latest and greatest, but my God, that game is going to look amazing and it's going to render so quickly, and the monsters are going to seem ever so real in contrast to, say, your 3-year-old's computer. And so this influences people who are interested primarily in graphics of some form. Games, again, Photoshop for designing graphics, movie editing, that kind of thing. But again, for normal usage, which I dare say is the common case, probably doesn't matter so much, but worth being mindful of. So let's not compare all of the numbers, but let's just take a couple highlights. So I see 256 megabytes of video memory here, contrast with 512 over here. So maybe, again, if I'm willing to be upsold because I'm a graphics person, maybe I should be mindful of this. But again, Google, I feel like I should read a review or two and see if I can at least get a technical opinion as to whether or not this matters. Most of this is the same, 8 to 9 hours, SD. Oh, here's another difference. I see 500 here for gigabytes hard drive, 320 here, but then 4 gigabytes across the board. So real world concerns, what should govern whether you choose 500 versus 320 gigabytes?
How much storage that you're going to be using?
Okay, so how much storage you're going to be using, and how might you even get a sense of that, right? I dare say a typical person might not even know how many gigabytes they have now, let alone want in the future.
What you're, I mean, it's what you're storing. What are you? It goes back to the first question: what you're using it for.
Okay.
If you're writing a ton of essays and you're storing them on your computer, that's fine and dandy. But if you're storing a lot of movies, you're downloading a lot of stuff, that's going to rack up your gigabytes very quickly.
Excellent. So that's quite true. What are you actually using the computer for? Not just in terms of what programs you're using, but what kind of data are you saving and creating and downloading and the like. It will influence how much disk space you need. So if you're, again, just writing like Microsoft Word documents, even big Excel files, you're probably only talking a few 10 or hundreds of kilobytes, most likely, maybe a couple of megabytes. But the things that really start to chew up space these days are what types of files? What are the bigger files that are in vogue these days? What's that?
Pictures?
So pictures, so high quality photographs can start to chew up space, especially if, back in the day you might have been a little more conservative with what you're taking pictures of because you have to pay for the film and replace it and the like. But now you can take 1,000 pictures on a camera, and are you really as picky as you might have been 5 or 10 years ago? Probably not. So even if you're not taking better pictures these days, you're probably taking more and of higher quality in terms of the computer quality, not the human quality. And so it's just adding up unless you're selectively deleting these things. Even worse than photos are what?
Music.
So music also adds up, especially the highest quality, and so movies. I mean, just the other day I was the last person in the country to see The Social Network, and I downloaded it through iTunes. I think it was 4 gigabytes, the HD version. HD meaning the high quality TV thing. It's widescreen and very nice quality, but 4 gigabytes. Now, in and of itself, okay, 4 gigabytes, but if your hard disk is only, let's say, 300 gigabytes, you can only do this so many times, right? You can't download more than 100 movies, because 100, that's 400 gigabytes. I can't download 100 movies. Now, that's maybe an exaggeration for anyone, but if you think about 20 movies, maybe, plus all your music, plus all your photographs, this space starts to get eaten up quickly, especially if you're saving the movies. It's one thing to rent it, and then it disappears after a few hours or a few days, but if you've bought it, or you've downloaded it and just want to, or you've ripped it from a DVD disc and you want to keep it, these things start to eat up space. And frankly, as any of you have probably experienced, whether it's at work or home, there's nothing more annoying, frankly, than running low on space and then having to waste time selectively going through your hard drive trying to figure out what to delete, not only because it's a nuisance, but also, maybe you kind of do need that, but you kind of need the space more. I mean, frankly, one of the things that's compelling about Gmail and these internet-based services these days is that they've really gotten us into the habit of not thinking about or caring about space. Facebook, too. There's no limit on the number of photographs you can upload, and frankly, that's kind of the way it should be. It's kind of an artificial problem to say, no, you must pick and choose among these bits because, frankly, storage these days, not so much for us, the consumers, but on the scale, is actually pretty cheap. The fact that you get so many gigabytes from Google means because when they amortize it across so many people, it actually is relatively cheap these days. And it's only going to get cheaper. So what you'll see over the next several years probably is just a mushrooming of the amount of data we're all keeping around. So with that said, that's pretty much the only differences. But what you'll find with most any of these vendors, I'm not gonna let myself get upsold. I'm gonna go the less expensive one, but then I'm gonna have some options as well. And there are a couple of technical interests that we'll see on a PC site too. So again, we have the choice in RAM, this time 4 gigs and 8 gigs. 8 gigs for normal usage might be kind of pushing it, to be honest. It's not bad. More is, in fact, generally better, and the marginal returns of more RAM tend to be higher than the marginal returns of like another 100 megahertz, another point something on the gigahertz scale there. But doubling your RAM, anytime you double something, feels like that's going to be noticeable in some sense. So maybe it's worth the additional, maybe not worth the additional $400, but you know why now, at least. You might want more RAM, running more programs and the like. What about this? Unfortunately, this is not as simple as small, big, bigger, because here we have 500 gigabyte serial ATA drive at 5400 RPM, 500 gigabyte serial ATA at 7200. So presumably bigger is better for some reason. Back to that in a moment. But then wait a minute, this seems like a step backwards, and yet they're messing with me. For $200 more, I can have 1/4 the space, pretty much. That seems a little curious. Or I can have twice that space, but I can spend $650 more. Or to get 512 gigabytes, so 12 more gigabytes than the default option, I can spend $1,300. So what the heck is going on here? What are some of the fundamental differences among these various options? So speed is one of them. So there's actually two types of hard disks in this list, and this is increasingly common in the Mac and PC world alike. There are the mechanical hard drives that spin, one of which is right here, and I'll pass this around in a bit. The ones in a laptop is smaller than this, but it's actually the same underlying technology. It's a mechanical device that's got like a phonograph record of sorts inside. Well, more on that in just a bit. And on that phonograph record of sorts are stored all of those zeros and ones in the form of magnetic particles that we talked about last week. Well, those platters, as they're called, those disks inside, can spin at different speeds. Very common is a speed of 5,400 RPM, RPM meaning revolutions per minute. So that means the circle inside of this hard drive is going to spin 5,400 times per minute. And faster is better. Now, why is faster better? Well, it means when you double-click that icon or you copy that file, you drag it from one place to another, the bits will move faster, so you, the human, will experience a faster response time from the computer. It will take less time to copy or save, say, a file. 7,200 RPM is generally the next step up. You'll often see, not so much in the consumer market, but the enterprise market, 10,000 RPMs. And also 15,000 RPMs for servers that are running websites and email servers and the like. Those tend to spin even faster because more people are affected than just little old me at my laptop. Yeah?
Assuming all the other bits can keep up the same speed, does that actually, would a 72 result in a half again as fast speed for your interaction with whatever it is that you're doing?
So it's a good question. So for instance, let's see. So this is like, it's almost a 50%, it feels like a rough, just shy of 50% increase. Am I really going to notice that difference? That's the gotcha, not necessarily. Even though 7,200 RPM is definitely non-trivially faster than 5,400 RPM, you really need to ask yourself, but is this device the bottleneck? Or is my RAM slow? Or is my CPU slow? Or is something else holding up the process that I, the human, would notice?
When you were talking about the two different brains, when you have the graphical processing unit, is that using the same cache as the CPU, or does it have its own cache?
No, so the graphics card would generally have its own hardware that's fundamentally separate from the CPU and its L1 and L2 cache and its own RAM. So what might affect it? Well, there's buzzwords that folks tend to use in computing, which is what you're doing with the computer CPU bound, B-O-U-N-D. This just means, are you using a lot of CPU more than anything else? Are you network bound? That is, are you just downloading a big file, which really doesn't take much thinking, just takes time for all those bits to come in off the internet? Or are you I/O, input output, or disk bound, which means, are you doing a lot of crunching on disk? Now, what might govern these various things? Well, we talked about gaming before. Gaming, frankly, tends to be very CPU intensive or GPU intensive, but you're not generally touching the disk all that much. You might be loading some new imagery, but a lot of that is all mathematically computed, so games and Photoshop and movie rendering software actually tends to be more CPU intensive than it is, say, disk intensive. But if, for instance, you're compressing a really big folder, you've got 1,000 photographs and you want to zip them all up in a .zip file, well, that's actually going to take CPU cycle because there's a lot of math involved in taking lots of zeros and ones and figuring out, if possible, a smaller pattern of zeros and ones to represent that same data. More on compression later in the semester. So there's different tasks that are either CPU intensive or disk intensive. So the point here is that, yeah, you might have a faster CPU, a faster hard disk, but if what you're really doing is gaming a lot and doing fancy things with Photoshop, that again might not be the bottleneck. What you might want to do is spend a few $100s more for the faster CPU. So I feel obliged to apologize that there's no simple answer here, but really these are just the kinds of questions that you can't go too wrong by answering incorrectly, and at the end of the day you probably have a budget you want to stick to, but it's at least the kinds of things that should go in mind and are generally not things that come up in conversation with a typical salesperson in a store. Yeah?
Maybe this is one of those stupid questions, but I want to just get my mind around it. Is RAM in the CPU?
No, RAM is separate from the CPU.
So what is the I know it's like the brain of the computer is the processor, but
For the CPU?
Yeah.
So the units of measure that are relevant for CPU would generally be gigahertz these days. How many something or others can it do per second? And 1 gigahertz is 1 billion things per second. RAM, by contrast, is most commonly measured by consumers at least in terms of size, like 2 gigabytes, 4 gigabytes, 8 gigabytes. But as we've also seen, its speed does exist too. This is 1066 megahertz speed, but the consumer generally has less control there because that's usually decided by the person who built the machine and decided this Mac or this PC will use this type of RAM and this speed of RAM.
RAM and the CPU, they both have to do with like what the things you're currently actively doing.
Correct. So RAM and CPU both have to do with things you're doing now. Yes, and the computer, the CPU does the math, does the thinking, so to speak. The RAM is the guy that just sits there with all of the zeros and ones, just waiting to hand them to the CPU for actual number crunching. Okay, so we only scratched the surface here. So I feel pretty comfortable, perhaps, with the idea of a hard drive. It's a mechanical device, spins around, bits are stored on it. Faster tends to be better, unless I don't actually need that speed. As an aside, there are some downsides of faster, and one of the reasons you tend to see slower hard drives in laptops is because faster things emit more heat. Heat is generally not good for battery life, for the comfort of the human whose lap the laptop is on, and so forth. And so slower can actually be a good thing in some contexts, so tuck that away perhaps too. But now we seem to have a fundamentally different type of option. I see serial ATA, otherwise known as SATA. SATA, and this is just the type of hard drives that are in vogue these days. For those familiar, the predecessor was something called ATA or IDE, and that was just a different technology, different type of cable. But frankly, these days, SATA is pretty much what you get, unless, and frankly, within a couple years' time, this will probably be the default in most models. You can get a solid state drive, or SSD. Is the acronym that people tend to toss around. So the name kind of hints at the distinction here. A solid state drive actually has no moving parts. It's purely electrical, much like RAM is purely electrical. But what's neat about an SSD drive is that it's persistent. It's non-volatile, which means even though there's no moving parts, when you pull the plug, shut down, all of your data, all of your photos, all of your videos actually stay on that device. So an SSD, frankly, is pretty much a bigger version of the USB stick that you might already own or carry around with you. But instead of just storing a gigabyte or two, as you can see, these things now exist in quantities of 128, 256, 512 gigabytes, which is pretty big. But, notice the price difference. Odds are you probably won't be so inclined to get pretty much the same amount of space by paying pretty much twice as much money just to get the state of the art. So thankfully, 1 or 2 years, this is probably not going to be as big a deal. You'll get it for a much lower price. But what might incentivize you, maybe not to be upsold to $1,300 more, but maybe you should be willing to sacrifice 500 gigs down to 128 gigs and spend, not all that much more, $200, because what might be the benefits of this clearly more expensive technology? Yeah, so faster. So we saw this last week when we talked about RAM and L2 cache and L1 cache. Every time you got closer and closer to the CPU, things were getting faster. And in general, faster is better, but we've already stumbled across some caveats tonight alone. Well, in this case, faster hard disk, faster SSD is probably not a bad thing, because it means when you double-click that icon or when you are saving your files or copying files around, you're actually going to start shaving a few milliseconds, maybe for big stuff, a few seconds off of your life, off of that progress bar. So it actually might indeed make a difference. In fact, boot up time is particularly affected by SSDs. There are fun tests. You can find YouTube videos comparing essentially an old school hard disk, the spinning disk type, versus a solid state drive. Boot them up and you'll see that one computer might take 30 seconds with the older technology, the other one 10 seconds. Now, is 20 seconds of your life worth another $1,300, for instance? Maybe not, but these are the kinds of differences that it starts to make. But it's not just speed. What else might be affected when you have no moving parts?
Less chance for things to mess up.
Yeah, so there's less chance for things to mess up. If there's no moving parts, I can be a little, maybe this is the wrong takeaway, I can be a little more negligent with my computer, right? Because if there's no moving parts, and we'll see in just a moment in a video, that there's no moving parts that can break or that can kind of gouge into this metal platter I've alluded to, because there's no moving parts. Things aren't going to shuffle around, scratch each other, and the like. So actually, SSDs are compelling too, because you don't have to be quite as worried about damage. And it doesn't have to be negligence. What if you just kind of bump it, or if you kind of drop it into your bag a little too strongly? So these are actually real-world compelling scenarios. Yeah.
How is memory stored in solid state?
So it's essentially stored electrically, but in such a way that the electricity sort of changes the state of the material that makes up the solid state drive, such that it stays in that state, even when power is lost for even a long time.
With the little magnetic fragment, I understand it being pointed one way or the other, but what are you saying?
So in this case, I'll see after break. Let me see if I have either a video or some pictures, because it's actually it's not as simple as the magnetic particles, which is why I brought the video of that first. So let me come back after break and see if I can do that justice. Yeah?
So this moving parts does not generate as much heat?
So if there's no moving parts, does it not generate as much heat? So that's possible. I think that one's more likely to be dependent on the actual hardware and how it's designed, but that's definitely possible, since there's less friction, and friction does tend to give off heat. Yeah?
And because it's not spinning, I had an accident some years back where I actually had the computer in this position when I
Okay.
put it up, and the directory was lost
Oh.
because of friction.
Interesting. Yeah, so we'll see in just a moment that I called this thing like a little phonograph record for a reason. There is a reading head, sort of like old school record players, that is what's moving back and forth and reading those zeros and ones off the disk. And if that thing touches the metal plate, bad things happen. Data get lost. And it doesn't, again, have to be a drop. You're sitting in bed with your laptop and you just kind of pick it up, but a little too harshly, and the thing is spinning and just wasn't quite well designed, or maybe something's already a little loose. Bad things can happen. Yeah?
So is 128 faster than 500?
Yes. So in this case, because it's solid state, in principle, it should be faster than even a bigger, slower technology. And I say should be because here too, I'm sure you could find sort of the worst possible SSD and the best possible hard disk drive, and they might actually be comparable. But in this case, when it's someone like Apple offering them together, there will be a speed increase from one versus the other.
Are you really paying that much for the technology, or is this like a supply and demand thing? Does it really cost them that much money to?
So it's a good question. Is it really a supply and demand that's dictating these price differences, or it's the technology? It's a little bit of both, to be honest. Like flash memory, more generally, solid-state memory is very much in demand these days because it's in things like our USB sticks, inside of our computers, inside of our TVs these days. But part of it, too, is the manufacturing, the technology and the cost thereof, and the fact that people are still using some of the older, slower devices because they're at a better price point. But it's certainly one of those things that will get better over time. Yeah?
Does a serial drive have to access memory sequentially?
Good question. So does a serial ATA drive, a SATA drive, have to access data sequentially? So in a sense, because you have this platter that's spinning in a circular fashion, it can only move from bits to bits by quote-unquote seeking, by physically spinning the disk and by moving this little record player head in or out. So in some sense, it does have to access it sequentially, and if it misses the data on one pass, it can then get it on the second pass around. Whereas something that's at least electrical, you do have random access to it, whereas at the end of the day with a spinning hard disk platter, it's necessarily sequential because the thing only goes in one direction. In fact, let's see if we can't pull some layers back here and take a look at one such implementation of this. So I'm going to go ahead and open up a AVI video. This is a technology we'll look at before long in our multimedia lecture. But what you'll see here is an artist's rendition of the inside of one of these things. Hard disks, at least of this flavor, generally come in two sizes. So this is a 3.5-inch hard drive. This is what you generally find in desktop computers for consumers and also in servers these days. They're reasonably heavy. They're generally vacuum sealed. This one, the TFs and I have kind of been pulling apart as best we can to open up, and you can actually see once we remove the last of the screws, the metal plate inside. Generally, you don't want to do that since dust is very bad, as we'll see in this video. But more commonly in laptops is 2.5-inch hard drives. So this is relevant is if you actually get to the point of upgrading a computer's hard drive, you certainly need to be mindful of what type of SATA drive you want, either desktop or laptop, or more technically 3.5-inch versus 2.5 inch. As an aside, the SSD drives, the solid state drives, are almost always 2.5 inches. They are identical physically to the spinning disks for laptops so that they are essentially compatible with the same connectors and the same openings in a computer. So let's take a look at this inside of a hard drive.
The hard drive is where your PC stores most of its permanent data. To do that, the data travels from RAM along with software signals that tell the hard drive how to store that data. The hard drive circuits translate those signals into voltage fluctuations. These in turn control the hard drive's moving parts, some of the few moving parts left in the modern computer. Some of the signals control a motor which spins metal-coated platters. Your data is actually stored on these platters. Other signals move the read-write heads to read or write data on the platters. This machinery is so precise that a human hair couldn't even pass between the heads and spinning platters. Yet it all works at terrific speeds.
So I did slightly oversimplify. In modern hard drive, there's actually typically more than just one platter. In this case, we can see 4 of them stacked ever so tightly as possible together. The idea being that with 4 platters, you can get as much as 4 times as much space on there. You might have seen in various contexts in life something that looks a little something like this. Anytime you see this green piece of plastic with lots of black and silver things on it, it's just generally called a logic board. And in fact, this thing here is not green, but it's still a logic board. They can come in blue colors and even brown and various things. But this, for instance, is a motherboard. This isn't technically a motherboard. This is just a logic board, but a motherboard is just a special type of logic board. The teaser for now will be this. This crazy looking thing here is actually the CPU that's inside of one of my former PCs. The CPU is always attached to something called a motherboard, and a motherboard is kind of like the central artery system of a computer. It's a big piece of plastic with all of these little metal wires, or traces as they're called, and that allows the CPU to talk to things like the RAM, which in this motherboard gets inserted here, things like expansion cards, which go here. An expansion card is like a special card you might need to get fancy speakers on your computer, or you might put a fancy graphics card in here. An expansion card expands the capabilities of your computer. These are kind of falling out of vogue, especially as people buy fewer and fewer desktop computers, but they're meant to add additional hardware to your computer after you've already bought it. And what happens generally is you put a card in here that looks not unlike something like this, slightly different shape, and then part of it sticks outside the back of your computer, and what's sticking out are the connectors that you can plug some cable into. Yeah? So what's the difference between motherboard and logic board? None really. Logic board is just a generic type of circuit board that you can plug stuff into. A motherboard is a logic board that is the so-called central artery system of the computer. The motherboard is a big logic board into which all the most important stuff gets plugged in. The CPU, the RAM, the expansion cards, something called ROM, and then we'll explore in a bit the various connectors that are on the back as well. But let's see, we can take a closer look at what's going on inside that hard drive. We see from this video that there are indeed these platters, but what's really happening on those things we'll see here in part 2.
Let's look at what we just saw in slow motion. When a brief pulse of electricity is sent to the read-write head, it flips on a tiny electromagnet for a fraction of a second. The magnet creates a field, which changes the polarity of a tiny portion of the metal particles which coat each platter's surface. A patterned series of these tiny charged-up areas on the disk represents a single bit of data in the binary number system used by computers. Now, if the current is sent one way through the read-write head, the area is polarized in one direction. If the current is sent in the opposite direction, the polarization is reversed. How do you get data off the hard disk? Just reverse the process. So it's the particles on the disk that get the current in the read-write head moving. Put together millions of these magnetized segments and you've got a file. Now, the pieces of a single file may be scattered all over a drive's platters, kind of like the mess of papers on your desk. So a special extra file keeps track of where everything is. Don't you wish you had something like that?
Right, so recall from last week that we did talk about these magnetic particles, and I think I depicted them with my hand or finger at the time. North-south is a 1, south-north is a 0. They're just using these blue and red particles here to represent the same idea, but it ultimately is just their alignment or their polarity that dictates what's actually being encoded. And we tore apart at the very end of class last week a floppy disk, which frankly is just a super cheap version of the same idea. There's not 4 metal platters, there's one cheap plastic platter, but there are those same magnetic particles on there that are actually doing the encoding of zeros and ones. And in fact, do you recall from when you were using floppy disk, you know how there was always that locking tab at the top corner that you could flip? So it turns out, if you've ever been sort of intimidated, frankly, by various pieces of technology, consider for just a moment at how simple that implementation of technology was. Notice what that little tab actually did and how it worked. So this is a floppy disk instead.
Onto a floppy disk, your PC tells the drive to send tiny pulses of electricity through the heads. The pulses make the heads act like little electromagnets. Each head creates a magnetic field that reaches the surface of the disk. Remember the magnetic coating on the cookie? The magnetic field alters the tiny particles in this coating. If current runs through the heads one way, the particles are arranged with their north and south poles in one direction. But if current flows through the heads the opposite way, the polarity reverses. To read data from the disk, the read-write heads move into the same position over the cookie, but this time the process is reversed. The cookie particles create a magnetic field in the coils of wire, and this creates a current in the read-write heads. The disk drive detects this flow of electricity and passes it onto the PC. The PC translates the back and forth current changes into a series of ones and zeros, the binary language of computer data.
So that's what happens by default when you stick a disk in the drive. But if you do flip that little tab, notice what's actually happening in that process.
The floppy drive you see here works with 3.5-inch floppy disks. They're the type most often used to carry new programs, save data, or to move files from one PC to another. The part of the disk we see is actually just the hard plastic shell. The working disk, which is inside, is protected by a sliding metal shutter. This thin inner disk, called the cookie, is coated not with chocolate chips, but with a very thin layer of magnetic material. When you slip the disk into your floppy drive, a system of levers pushes back the metal shutter. The levers also pinch 2 read-write heads closer so they almost touch the cookie. A motor at the base of the drive spins the cookie based on commands from your PC. The PC also signals another motor to move the read-write heads back and forth over the surface of the disk, so they can read or write data. Before your PC writes data, your drive first checks the Write Protect tab in the corner of the floppy disk. If it is open, light from a tiny diode shines through and strikes a diode on the other side. This diode then says to your PC, "Don't write on this disk." But if the tab is closed, no light gets through, and the PC knows it's okay to write data.
So it's kind of fascinating, right? It's just a silly little sort of low-tech implementation of a technology that just kept all of your data safe and prevented that drive from actually writing anything more to a disk back then. Oh, that's not a question. Oh, that just means we have 3 minutes of tape left. That's okay. Other questions? All right, why don't we take a 5-minute break, and we'll then dive back in. All right, so we are back, and this demo just got a lot more interesting thanks to one of your classmates who had one of the less common screwdrivers on his person. So here we have on this little USB camera the motherboard that I held up earlier. This was from a pretty recent computer, just a few years old now, that just died on me, and so I gutted it and took out the parts so that we could actually use them in class. And the crazy thing that is here is indeed covering up the computer's CPU. So I think we had this picture last week that depicted this thing called the Core 2 Duo, which is just the marketing brand name of a very popular CPU right now. But if you flip over a modern CPU, what you actually tend to see are a lot of pins, these little gold pins, and each of those pins is like an individual wire that needs to make contact with some part of the motherboard. But the gotcha with CPUs is that they actually tend to get pretty darn hot these days. And so when they're installed into computers at the manufacturer, or even by you if you're a hobbyist who builds a computer yourself, generally the CPU is not as pretty as this nice little logo here. Instead, they slather some special glue or paste on top of the CPU, and then they mount something called a heat sink on top of it. Heat, H-E-A-T, sink, S-I-N-K, and this is just a fairly cheap piece of metal with a lot of surface area, a lot of prongs, and a lot of shape to it, so that there's a lot of opportunities for airflow to pass over this heat sink and move heat away from the CPU elsewhere, to the back of the device or elsewhere inside of the case. And so one of the reasons that desktop computers and laptops have fans are to move that hot air out of the way of the CPU and try to keep it as cool as possible. And as an aside, some of the fastest, fanciest CPUs, at least in special computers, frankly, are even liquid cooled sometimes to actually keep them at a very low operating temperature so that things don't overheat and essentially melt down and mess everything up. So this is what is plugged into this board at the moment. If I switch back to the camera here, I'm going to actually pop open a cheap little metal clip that's holding this thing on. I can then remove the heatsink itself. And so now what we have here, I guess I did this demo before. I took the CPU with me. OK, we have the holes where that CPU would have gone, and we just have the heatsink. Apparently, I stole my own CPU for some reason. Oh, you know what? That's what it was. The motherboard died, but the expensive CPU did not. So I kept the CPU at the time. But I had the foresight, apparently, to trick myself by putting the heatsink back on. So anyhow, this is a heatsink. This is a few cents and no computational power. This is the motherboard, which ironically has no computational power either, because what used to be plugged into all of those little holes is exactly something that looks like one of those Intel Inside CPUs. Now, why all of those pins? Why all of those connectors? Well, there's a whole lot of connections that this CPU wants to make with other parts of this motherboard. So down here on the bottom left, these blue slots, though the color varies by manufacturer, looks like this computer can fit 4, or rather 3, in this case, DIMMs. There's different types of memory. There's different shapes, so to speak, of memory. DIMMs, D-I-M-M, tends to be one of the more popular. RIMS, R-I-M-M-S, is another one. And these just refer to the form factor, the shape of the connector. This is not something that you really have choice over. You don't get to say to the manufacturer, oh, I'd like to use this type of DIMM instead of this type of DIMM. It's dictated by the person who made the motherboard and the computer. But it is relevant if you want to try to save some money and not go back to Apple, not go back to Dell or IBM, and you want to go third party to some random website or reputable website, buy RAM and install it yourself. You need to know those specifications. And generally, you can figure this out by checking the user's manual or going to some menu in your computer if it's still on and working okay, and find out what kind of RAM is inside of there. Thankfully, some of the best websites today actually give you step-by-step instructions for what type of RAM your specific computer has, because someone else went to the trouble of figuring out all of the makes and models, so you don't have to read the fine print yourself. So other connectors on here, this is what was called an AGP slot. This is falling out of vogue these days, but it was a type of graphics connector. These things up here are PCI connectors, peripheral component interconnect, and these are just big acronyms that describe expansion technologies. Interfaces, slots, into which you can plug those things called expansion cards that just add more connectors on the back of your computer usually to let it do more things. Another example that comes to mind that I used to have when I wanted to watch TV years ago on my computer and therefore run like the antenna cable into the back of my computer. Well, my computer by default didn't come with one of those little coaxial antenna plugs. I had to buy a TV card, open my computer, slide it into that, and then I had that little metal circular connector that I could plug an antenna or a cable line into. So that's another example, but not as common these days as, frankly, people move more and more to laptops and devices that have more features out of the box. Then there's some connectors on the back. We'll come back to those in just a moment. Let me pass this around. You really can't do any damage, so don't worry about touching things, but do realize it's actually a little prickly, or you can definitely cut yourself on the bottom, so just be careful where you pick up.
What's the second heat sink for?
The second heatsink, and this one here, that's probably the GPU, the graphics processor, but I'm just hypothesizing because it's been a while since I read up on my own motherboard specs. But most likely that was the second hottest device on there.
Have you built your own
Have I built my own computer? Yeah, a couple times, and it was fun at the time. Nowadays, frankly, it's a lot easier to drool over something that someone else has built and just get that. And the funny thing is, too, it depends what you're looking for. You can actually save money, ironically, by not building it yourself and getting something off the shelf, because you can get such deep discounts sometimes, not so much from Apple, but by Dell and other vendors that have a surplus of the hardware, or they just manufacture it in such bulk that you can get better prices. But it was a lot of fun. But I still remember to this day holding my breath when I plugged in the innumerable little wires and connectors that are not even pictured on our videos here because it's simplified, and just being amazed that my own computer worked. So, other questions? So, which is to say, it's definitely fun and worth doing. And the research process itself is fun because you get to decide for yourself, what type of CD-ROM drive do I want? What type of RAM do I want? What kind of CPU do I want? All of this. And it's got to all be compatible. You can't just choose anything. But it's a lot of research, not necessarily financially compelling, but for a geek sort of satisfaction, it's definitely high returns. Other questions? All right, so what else? Well, thanks to your classmate, you can now see not just the outside, but the inside of this hard drive. What you'll see in a moment, that this is actually a pretty old hard drive in that it literally only has one platter inside of it. You're welcome to touch this too. You'll notice that fingerprints stick to it very easily. This too would be very bad in practice. The moment we broke the vacuum seal, we killed whatever data was inside of this thing. But you'll see that there's relatively few parts, and you can spin this thing around. It is kind of like a record. Whoops. It is kind of like a record, and this is kind of like that reading head that we saw in cartoon form just a bit ago. So again, you don't necessarily see you won't see these in laptops. You will see these in desktops this size. You'll see a smaller version of this by another inch or so smaller and thinner inside of laptop computers, but in a few years, probably SSD or some successor will be all the rage, even to those things. All right, so what other toys do I have here? Okay, so here's some particularly retro RAM. Honestly, each of these sticks, these are probably SIMS, S-I-M-M-S, which is even older. Frankly, even though it looks like there's a lot of somethings on that bottom one, it probably is like 128 kilobytes. Maybe it's a megabyte. It's probably pretty small. And it's just been so old and sitting in a box for so long, I don't even recall. But back in the day, this was probably a lot of RAM. But these days, a typical computer, as we've seen, will take 2 gigs, 4 gigs, or more of RAM. So why don't I start one of these here, one of these here. And again, if you're upgrading your own RAM, probably not so good to touch the gold or the silver contacts, especially since all of us have a lot of grease on our fingers. Even if you're nice and clean, it's just oils from your fingers will get on it. Those are, in fact, the things you can buy third party. So let's do that. If you do, in fact, have a desktop computer or a laptop computer, whether it's a Mac or PC, what are your options? Because frankly, if you've got a computer that's 1, 2, maybe 3 years old, there's relatively few opportunities to sink more money into that device to actually squeeze some more life out of it. So most likely, you're not going to upgrade the CPU, because upgrading the CPU to anything faster, frankly, is a fairly delicate operation. And also, generally, when new and fancier CPUs come out, they need newer and fancier motherboards, which means you need a new motherboard, which means there's all these ripple effects, both in terms of price and just in terms of labor to actually do this, that at that point, you're probably better off just getting a new computer. But one of the relatively few user-serviceable parts in a computer is, in fact, the amount of RAM. Thankfully, some vendors make this easy. You remove like one screw on the bottom of a laptop, and voila, you can just plug in a special DIMM or some kind of chip, and that gives you more RAM. You might have to remove an older, smaller one. Desktop computers involve opening the big case on your desk or under your desk, finding the motherboard, wherever it is in the room, and then sliding in those little chips of sorts that we're also passing around in the form of RAM, so that they snap in. But it really does depend on vendor. But I would say if you're in this market, there's 2 places to start. So Crucial is actually a company that manufactures, among other things, RAM. By default, they're going to redirect me to the Mac site, but I'm just going to go to the generic site here, and you don't need to get sort of distracted by a lot of the links and such here. What's really nice about Crucial is, at least if you have a brand name computer that's reasonably new and was popular and wasn't some special one-off type of thing, most likely, you can find it in the pop-up. So I'm going to choose, for instance, a computer I have had. So you can see there's all sorts of vendors. Let me zoom in. You can see, frankly, there's some vendors I've never even heard of. So even if you do have a sort of no-name computer, so to speak, odds are it might still be on here. But I'm going to go with one I know, Dell. And then notice in step 2, I choose the product line. Again, these should mean nothing to most of us unless you actually have one of these computers. But one I'm thinking of is called the, what is it called? Precision Workstation. All right, and then step 3 and final is which model it is. And actually, I don't remember my own computer now. I think it was something like T3500, let's say. So here I found it. My model number of my computer. I choose this. I'm now prompted to click Find It. And what's nice about Crucial and companies like it is they've done all the busy work of figuring out what the compatibility is, what the maximum amount of RAM is. Do I have to install them in pairs? That is, do I need to put 2 sticks in at once, or can I do one at a time? Because there are some of these technical gotchas that you would find in your own user's manual. Frankly, I would conjecture that most of us don't have our user's manuals anymore, or never even once opened it, and that's probably fine because everything is available online these days. But what's interesting here is that this computer, even without opening it, I can see that I apparently have 6 slots, in contrast with that older motherboard's 3 slots. At top right here, it happens to tell me the chipset that this RAM is supposed to use or support, that this computer is meant to support. Notice, though, that there is a limit. It looks like the maximum amount of memory is 24576 megabytes, or really 24 gigabytes. Yeah, 24 gigabytes of RAM. So remember, giga versus mega is a factor of 1,000 difference. So if you take what's megabytes there, 24576, and move the decimal point 3 places over to divide by 1,000, you get 24 gigabytes, give or take. So that's worth keeping in mind, because even if you want to go crazy, you find some amazing sale, you buy 32 gigs of RAM, it's not going to work. It's not going to fit. So you need to be mindful of this. Well, what else is there to know here? Frankly, there's lots of FAQs that help avoid some common mistakes, but what we're going to look at instead is down here. So you don't have to buy it from this place. Frankly, sometimes I use Crucial just to figure out what's inside of my computer, and then I go find it for less elsewhere once I know what I'm looking for. But you can get a sense of numbers here. Frankly, it's pretty darn compelling. I can get 12 gigabytes of RAM for this computer for only $150. Now contrast that with what we just did with Apple, whereby if you want to get 2 gigs to 4 gigs, you're going to spend, what was it, $200 difference, I think? And yet for less than that, I can get 12 gigabytes, albeit for a desktop computer, in this Dell computer. So there's even differences in the desktop versus laptop world. But it's kind of exciting. Frankly, if you're feeling like your computer's a little slow, it only came with 1 gig of RAM, but it apparently supports 24 gigs of RAM. Frankly, upgrading it to 6 gigs, 4 gigs, something in the single digits, might not be unreasonable, especially if it is, in fact, a desktop computer. Another place to go, just so that we're not biased toward one in particular, dealram.com is another good site. And it's a little more technical, but it too has a bunch of drop-down menus from which you can choose your vendor and the make and the model. They tend not to be quite as up-to-date if your computer is particularly new, but they too are sort of a comparison engine where you can buy it from all sorts of places. But I would beware. Frankly, this comes with kind of experience or with recommendations from friends. In general, buying computer stuff, I wouldn't go with someone no-name. Find at least one friend to say, oh, I've bought from them before you dive in. Newegg is very popular. Amazon is very popular. CDW is very popular, but there's so many like fly-by-night kind of places that you probably don't want to buy from because you're just going to get mired in return issues or quality issues. It's sometimes better to go with someone that's well-known, even if it's generic hardware, generic RAM. Okay, so that was a lot all at once. And even though we focused on Macs initially with sort of the walkthrough, the same numbers and the same types of technology would occur even in the PC market, especially when it comes to RAM. So any questions on sort of that process and the technologies that arise throughout the discussion? No? All right, so let's see if we can't tone things down to just make things a little more familiar for a moment, and then see if we can't tease apart some of these technologies. So the motherboard is still going around. Can I steal this back? Perfect timing. So thank you. On the back of computers these days, there's all sorts of things. And lest I forget, your unofficial homework assignment for this week is to either take your computer, or better yet, not your computer, and at work or at home, unplug every single wire that's in there from the back of the computer, and then challenge yourself a few minutes later, once you've forgotten where everything went, to figure out where everything should go. Now, I'm actually quite serious here. What you'll see on the back of the computer, frankly, is that the industry has made this relatively easier these days. Frankly, a lot of things are color-coded, and even barring that, they're almost always shape-coded, whereby different shapes fit in different things. And frankly, one of the best lessons to take away from a course like this is that you shouldn't touch like the metal contacts on the RAM when you're installing it. You shouldn't be putting your hands all over your motherboard when you open it up, but externally to the device, laptop or desktop, you're not going to break or screw up your computer all that much by just kind of playing or experimenting, albeit gently. I think one of the biggest things that get in the way for neophytes with computers is just being wary of breaking anything. It's kind of hard to do some damage. And I say that having opened up computers and doing exactly what I'm saying not to do, and they're still working just fine. Best not to do this either, especially on carpet. But again, it's kind of just common sense. I probably shouldn't have done that right now because I'm going to feel it in a moment. But in short, be a little more adventuresome, I would, after a course like this. So what's going on the back here? So this is, again, from a desktop computer. So you're going to see ports or connectors that you wouldn't necessarily on some laptop computers. But let me see if I can stop moving this around in my hands and focus on it for just a moment. So let's see if we can't pluck off some of the more familiar items here. So on the right-hand side, on the top right, oh, it's reversed over here. On the top left, we have a little green thingy and a purple thingy, for lack of a better description. Anyone familiar with what these are?
Keyboard and mouse.
Yeah, so it's keyboard and mouse. Now, frankly, you can almost always identify that by, again, just the color or the shape of the thing on the other end of it, the keyboard or the mouse, or the color or the little icon. But let's actually put a little more technical rigor here. So those are generally known as PS2 ports. This is one acronym that can kind of go in one ear and out the other because these are kind of falling into disuse finally. Generally, people are using a technology called USB, Universal Serial Bus, to replace PS2, in large part because USB ports are just much more versatile. So on this on this video here, which is the USB port? Anyone know? Yeah, so far end, top right, but below the funky looking thing. So those rectangles that are right, let's say here, there's two of them, here and here, those are USB ports. So USB is faster than PS2, but it's more versatile in that you can plug all sorts of things into them. And it took a while for this technology to catch on, but odds are if you've got a pretty modern computer, your keyboard and or mouse are using a USB connector at the other end, certainly if you're using a Mac, and most likely if you're using a PC, but PCs have clung to PS2 technology for quite some time. Macs never used it. They used something else. But USB can power all sorts of other things. What else might you have at home connected to your USB port? Okay, so keyboard, mouse, printer. What's that? External hard drive. So as an aside, this same hard drive that we passed around here and opened up, if you've got an external hard drive, frankly, it's probably about this size and weight, maybe even a little bigger, but with sexy plastic and blinking lights and all of this. What's inside of there is most likely something like this. Now, newer with more platters and more disk space, but those external hard drives are generally SATA drives that have a power cord coming out of them, that have a USB cord coming out of them, but some kind of adapter, so that even though the hard drive might have this connector, there's some plug that's converting it essentially to USB. And so really the technology you're buying now, from Staples and the like, is the same thing that was or is in some desktop computers. And they sometimes use smaller drives just for cost reasons or for heat or for power reasons as well. That's all an external hard drive is that has moving parts. What else can you connect to a USB port these days?
Memory sticks.
Okay, memory sticks, so like memory card adapters, because the stick itself wouldn't go into the USB port. So let's say memory adapters. A couple other comments? Yep. Yeah, so flash drive. Okay, so I'm going to put that in the same bucket here. So memory adapters or flash drives, like your USB stick. And again, here too, another takeaway from this week in particular, there's so many synonyms out there for, even though they might have subtle differences, really are the same thing. So like USB stick, flash drive, jump drive. I mean, there's a lot of stupid words that all ultimately describe the same thing. And the important thing, frankly, is do your quick Google search or the like and just tease apart what's really being talked about. Yeah. Yeah, so iPods, iPhones, iPads, all of these kinds of things. So you can see from the length of the list, it's kind of excessive what gets plugged into these things. So iPods other MP3 devices, whereas again here, we pretty much had keyboard, which geeks tend to abbreviate KB, and mouse. Printer scanners would go there, even fax machines that have scanners. What's that? The flip camera, those HD flip cameras. So let's say cameras, scanners. I mean, frankly, it really is or has become a universal serial bus. Sorry?
I got a second video card plugged in.
A second video card plugged into USB. Oh, interesting. So even external cards as well. Oh, okay, to monitors. Cool. So lots of stuff. Lots of stuff. But there is a gotcha. It's actually not all that fast, relatively speaking, these days. So an alternative, especially for external hard drives, is not to use USB technology, but to use something called, especially in the Mac world, FireWire. So FireWire is a newer technology. It's not depicted on this motherboard, because mine was too old at the time to have this built into it, that you can have a FireWire card that plugs into this motherboard that gives you these ports. FireWire tends to come in two flavors, essentially A and B, B being faster. And by faster, I just mean when you plug something into this port, whether it's USB or FireWire A or B, the faster it is means the more bits that can flow back and forth. Now, who cares? Well, FireWire is particularly compelling if you've got like a camcorder and you want to copy your home movies onto your computer. Faster is better. More bits means you don't have to wait as long for the kid's video to get moved onto your computer. If you're just connecting a external hard drive that's got all of your movies, like Social Network and many gigabytes worth of movies, well, if you want to copy those to or from your own hard drive internally, the faster the connection you have, the better. But not all computers come with FireWire. Macs do tend to, since Apple does tend to ride that kind of technology curve in the newer and better direction a bit sooner than PC manufacturers in general, but exists for both of these platforms. So other connectors that are actually on here. Some of these are a bit retro these days. The top pink thing is what was called a parallel port. You can still find this on some desktop PCs. It was generally for printers, maybe for scanners, and its little trapezoidal shape is what helps identify it. Below that are what are called serial ports. These are particularly dated these days. You would connect something like an external modem, the thing that made the funky sounds on the telephone line years ago. You would connect a joystick, an old school mouse to these things, but they really haven't been in active use for some time, at least among consumers. At the bottom, and this color is kind of washed out, but they are apparently pink, blue, and green. Those are the various sound connectors. I think green is usually headphones or speakers output. Pink is microphone. Blue is line in, which means if you want to connect like your CD player externally to the computer, you can pipe it through there, but you can just read the little icons generally. And that's about it. Oh, the top right one is pretty germane these days, or at least was. The top right looks kind of like a fat phone jack, but it's actually what? Yeah, so it's what's called RJ45, or more simply, an Ethernet jack. So that's what you've been plugging Ethernet cables into, whether for your home or for your work connection. Now, there's no connection, obviously, for a wireless connection, but even desktop computers can have Wi-Fi capabilities, generally by way of those things called expansion cards. So one of the computers I have at work, in fact, has this silly little antenna coming out of the back because I installed a card into one of these slots. The antenna sticks out the back and therefore means I don't have to run an Ethernet cable to my desktop computer. I can put it in any room I want so long as there's electricity. Yeah?
So physically, what's the difference between the inputs that determines how you're passing the data from a device to the computer? And if it's not just hardware, then what's the difference in the protocol for the input?
It's a good question. Can you try to be a bit more precise? Or give an example?
Well, if I'm designing something,
Okay.
a new piece of hardware, and I'm figuring out how I want to connect it to a computer.
Good question.
What goes into that decision? If I want it to be fast, I'm going to choose FireWire. But is there something that's going to be physically easier about using a USB?
So that's a really interesting question. So if you are an engineer or a company owner who actually wants to design a new device, maybe it's the newest like flip camera, the newest iPod, you have to make a decision at some point, how do you want this device to connect into a user's computer? There's a few different factors that weigh into that. One is, do you want it to support Macs and PCs? If so, you want to make sure you're choosing something compatible, lest you have to invent two different types of cables. And to be honest, you're mostly limited, most likely, by what people actually own. So these days, USB ports are pretty much omnipresent, which make them a pretty compelling option. Relatively fewer people have FireWire ports, by contrast. And so frankly, one of the judgment calls a lot of vendors make, even with these external hard drives, is they will actually support USB, because it's pretty universal, means anyone in the market can buy their device, but it will also come with a FireWire A connector and maybe also a FireWire B connector. Might not come with all the cables in the box. You might have to buy the extra cables. But to be honest, a lot of the decision is, one, omnipresence of the technology. Two is the cost. The fact that USB is so omnipresent, it's relatively older now and slower, means it's most likely, if you want to buy the physical hardware, a little less expensive these days than the latest and greatest. But the gotcha is that if you're looking on the shelf at a hard drive that can transmit data at 20 megabytes per second and another that's 40 megabytes per second, but I need this technology versus that, you don't want to lose out to your competitors by only supporting the most universal. So to be honest, a lot of the decisions these days is let's be as compatible as possible. So case in point, these silly card readers that have 7 different connectors in them just so that you can buy one device. Yeah.
Can I ask a follow-up?
Yeah.
So, I guess physically, why is data transmitted faster with FireWire versus USB?
So it's a good question. Why is data physically transmitted faster with FireWire versus USB? So the short answer is technological advances over time in terms of the quality of cabling that's actually used and how the data is transmitted, whether it's electrically or in the case of the networking world, it's often transmitted these days optically with little flashes of light, essentially, in something called fiber optic cables. More expensive, faster, took longer time to develop, but exists. In the case of USB and FireWire, I mean, a lot of it is engineering research. It took time to figure out how to transmit data that quickly with high probability of correctness so that there's not a lot of data corruption along the wire. So, and the thing is, there will be something even faster in 2 years as the world sort of marches on.
What is FireWire though? Is it a plug-in or is it an actual cable? Or
It's a good question. What is FireWire? So FireWire itself is essentially a protocol. It's a standard that Apple and others decided on that said if you want to support this thing called FireWire, or it's also an IEEE standard if you're familiar with IEEE, an engineering organization that helps to standardize these technologies, there's essentially a document somewhere that says if you want to implement a FireWire device, your cable must be able to transmit data at this speed with this kind of probability, with this kind of success rate. It must have a connector that looks like this, has this many pins, where the top left pin carries electricity, the bottom left pin is the ground wire, the top right pin does something else. So it's FireWire is a standard that says what the cable should do and how it should do it and how the computers at either end should actually expect data to be transmitted. So it's a whole sort of protocol and specification. And USB is really the same way. Ethernet is also the same way. Almost always when we have in the consumer market these buzzwords that describe technologies, they're actually backed by long PDFs that standardize what they do and how they work. And one of the gotchas, as an aside, to make this a little more interesting, Apple in particular with their iPods and iPhones for years, always were a bit annoying in that in iPhones and iPods, if you have one or have a friend with one, it's not a standard USB connector. There's actually a few USB connectors. There's the one we see up here. There's a smaller one that cell phones tend to have, and there's an even smaller one that other cell phones tend to have. Yet Apple has their own annoying proprietary connector that for years they didn't publish even the specification for it. So if you want to make, you're some random company, especially in some other country, that wants to make a compatible device for power, for car radio, for headphones or whatever, you essentially have to figure out how that connector works so that people can buy your product and not necessarily the standard Apple product. And it's not perfect. So in this case, Apple doesn't necessarily show the world what their PDF is. They don't specify how the cable is supposed to work, what all the pins do. And in fact, if you try to plug in a third-party power adapter into a lot of iPhones, you'll get a little warning saying this is not a compatible device, but it will still charge your phone because not all the manufacturers have figured out what it is that's special about that cable and that plug that Apple has designed in that way. So FireWire, thankfully, open standard. USB, open standard, but that's what it ultimately boils down to, these engineering designs.
To get into technological red herrings trying to prevent reverse engineering,
Oh.
when they're designing something
Mm-hmm.
like that, do they intentionally
Oh, do they intentionally make it harder to reverse engineer? I'm sure. I mean, there's a financial incentive for the companies to not use compatible hardware sometimes. In fairness, it's arguable that Apple chose this connector because they were trying to make a fairly small device, and there's a lot of things that just don't fit into the side of the computer. But there's also value to them in sort of locking people into their own technology. And I actually wish I had it here. Chris, do you have our set of dongles, perchance? No? OK, so can't do a demo on the fly, but you might have seen these things. At least the PC world has these too on some laptops, but with far less frequency. Because Macs are getting so sexy and thin and all of this, they're making them sexy and thin by just removing all of the useful parts from the outside of them, including the connectors. So if I want to connect this monitor like I did today, I need one of these things, yet another dongle. And the thing I was mentioning to Chris here is that for one of my courses, like an idiot, I carry around for one course a stack of these things that's bundled together. I think there's 8 different dongles that Apple has made over the past 5 or 6 years for all of their computers, with a different end here and a different end here, and it's absolutely atrocious. And it's just because they keep essentially changing their mind or making it smaller and better. But the downside is, often you'll see me forget this. I didn't remember my tools today. I rarely remember these things, and you can't even use them across all platforms. So that was really a digression. But dongle, I give you. Other questions? Yeah.
Sorry if I can keep the digression going, but
That's fine.
So I bought one of those cheapo power adapters for my Mac.
Mm-hmm.
And the anecdote story is that it really messed up my battery, and I started noticing a lot of other things going wrong on my computer. And so my question is, I can see why it would mess up the battery, but things like networking seem to be a big issue. And is this just my imagination, or can you think of any hardware reason why it seems just that it was a lot harder for me to actually connect to wireless networks?
Good question. So to summarize for those at home, you're using a third-party power adapter. You've noticed that it might have had a deleterious effect on your battery, but also you're having weird networking issues. Short answer, it's most likely a coincidence, to be honest, but it's possible if that, especially these third-party adapters, aren't maintaining a steady 3-volt connection to the computer. If you're getting fluctuations in the power, that could be affecting it. If you have a lot of electromagnetic interference around the brick that's connected to your computer, that's interfering with the networking signals. I mean, I'm making some of this up, but it's possible. Most likely, it's some other issue that happened around the same time, to be honest. Other questions? All right, so let's try to reinforce that this stuff is indeed omnipresent, lest it sound like we're only talking about Dell here. So let's pick another one. Let's go to, let's say, someone easy, Lenovo.com. So Lenovo took over from IBM the series of ThinkPad laptops that are actually very popular in business. They're kind of boring computers aesthetically. They're kind of very rock solid, well made. So they're actually very good computers. And now they are taken over by a company called Lenovo. So I'm going to go to products here. I'm going to go to ThinkPad laptops. And frankly, and here too, to assuage, especially if you're among those less comfortable when it comes to this stuff, like many manufacturers just do not make this process any easier, especially for people who don't really know what they're looking for in the first place. I mean, where do I even begin? T-Series, Edge, X-Series, X-Series tablet, L-Series, L-Series, W-Series. And this is assuming I even found my way to Lenovo.com, right? I haven't even started looking at other manufacturers. So again, an important takeaway, frankly, is that if you're ever feeling overwhelmed or confused by this world in general, frankly, it's probably not your fault. It's their fault. And so not to pat them on the back too much, I mean, one of the reasons that Apple has gained in popularity is because, at least in terms of presentation, they've kind of simplified things down without dumbing things down, right? There were still some numbers that might go over one's head, but at least they presented it a little more simply. Now here, having known some of these lines, or I have a friend who has, let's say, a X-Series tablet. So I'm going to click on this thing. I'm going to click View Series. And again, this is just all useless fluff that's trying to distract me from really just finding what I want to do. But what I want to do is configure a computer. Looks like this one starts at $12.99, so it's in the same ballpark as what we saw. I don't need to see a history of the tablet. I just want to buy a tablet. Real notebook. OK, view mod. All right, so I mean, here too, this is frankly idiotic. The fact that I had to hover over a little link to figure out how to see more models. So if you were feeling confused on a site like this, so was I there, a little momentarily. OK, here we go. I'm ready to buy. So what is this thing? So this too isn't. It's not so much in vogue because the word tablet has now kind of taken on a different meaning. If you've seen the iPad or the Samsung device or the various Android devices that have come out, tablet is kind of becoming these iPad-like devices where there is no keyboard, there's no swiveling, there's no moving parts really. There's just a glass screen that you can touch and interact with. But another form of tablet is essentially a laptop whose screen swivels around somehow so that you can not only see it as a normal laptop, you can also write on the screen. Though frankly, these have never really caught on all that much, but they do have some compelling uses. Even for a class I've taught, we've used them for grading more efficiently because we could write on students' submissions as well as type more efficiently. We can circle things. If you're the type who reads papers a lot or reads academic papers or is a teacher and wants to mark things up, being able to draw on the screen but also use it for normal purposes is actually pretty compelling. So this device here, if we dive in, let's just see if we can't get to some specifics. And sure enough, here we go. So we'll see some familiar buzzwords now and some configuration options. So here, I'm a little overwhelmed at first by the specifics. Intel Core i5 520UM processor. I mean, that's a lot to absorb. But notice some of the familiar stuff. There's a mention of gigahertz, which is the speed. There's mention of i5. We did see that on Apple's site. And indeed, both of them use Intel hardware. There's some new stuff. There's something called L3 cache, in fact. So we talked about caches last week. More feels like it's probably better, but probably not a configurable option. FSB, front side bus. This is referring to the memory speed or the speed of the parts of the motherboard inside of this computer. Again, not something we really have discretion over, but at least a detail worthy of note. The operating system that comes with it in the Windows world, as we'll see in the movie next week, there's Windows, there's Mac OS, but within Windows, there's Windows XP, there's Windows 7, there's Windows Vista, there's Windows ... whole bunches of versions. The display here, a lot of acronyms in the PC world, and this is, again, because you have such diversity in the PC world, there's frankly there's even more buzzwords and acronyms out there, like the types of display, WXGA, that tend to distinguish things. But generally, again, reading reviews on various websites or looking up, frankly, just some of the terms on Wikipedia, more on that in a moment, you can get a sense of what some of these new terms are. 2 gigs of RAM, 500 gig hard drive, something about wireless, but more on that in our internet lectures. Well, let's try to configure this thing. Customize and buy. Well, let's see what I get some discretion over here. Customize, contacting website, ... OK. So they've taken a different approach. Dell's website actually looks a little familiar where they break it down by category. But it looks like I have a little discretion here. I can either have the first CPU or the second CPU. And it looks like the numbers are just more all around. And the price difference is very consciously not shown. Oh, there it is. If you hover, oh, there it is. Very light text, $100 for a different processor. But here, too, is you can't necessarily compare CPUs as though they're apples and apples or oranges and oranges, because notice the difference here. Intel Core i5 520UM, whatever that is, some model number, 1.06 gigahertz, 3 megabytes L3, 800 megahertz frontside bus, and then the next one is the i7, which is the next model number up, but it's 2.13 gigahertz, 4 megabytes of L3 cache, 1066 megahertz frontside bus. Seems amazingly faster. But again, it doesn't necessarily mean it's twice as fast, especially if the disk is what's relatively slower or you are the bottleneck in the whole process. So again, when it comes time to just about pull that trigger, we would encourage you certainly to read just a couple reviews. You don't have to go buy magazines. You can generally Google around for the model number and find someone reasonably reputable like PC Magazine, PC World, and Gadget. We'll post over time some links on the course's websites to places that you can at least start to familiarize yourself with. I'm going to click Next. I'm going to choose this here, the operating system. So who cares about this difference? Well, we talked about bits last week, 32-bit, 64-bit. Indeed, and within the Windows world, there's different flavors of Windows, even the same versions. There's the 32-bit version of Windows 7, the 64-bit version of Windows 7. These days, you're probably safe going with the 64-bit version. Generally, things will be faster. It's a sign of the times. But if you're using, for instance, some special program at work, interpret as you will, but that maybe is 5 years old, even 10 years old, you might be stuck not being able to use it if your operating system is 64-bit, but that software is only quote-unquote 32-bit. So if you need to, if there's some special tool that you use or you have to use, best to read the fine print or ask someone if it will actually run on a 64-bit OS. All right, moving next. What else do we got here? Microsoft Office, so this is just user software that you're probably familiar with. Windows XP mode, what does this mean? Well, you might have read over the past few years that the world hated Windows Vista overall, such that most people stayed with something called Windows XP, which was a pretty good operating system, pretty stable. And why spend money upgrading your computer if it just works? Well, that was a problem for Microsoft. And the world has received Windows 7 much better, but there's still many mentions of XP anytime you buy a computer, because there's a lot of companies and even a lot of consumers who just don't want to deal with upgrading if it's not going to do anything more for them. So that was an interesting thread in the media for a while. Type of screen here is an option, and here we get RAM, and again, ... But the point here really is not to compare, in this case, a Lenovo and Apple outright, but to show the similarities. Really, it's the same kind of hardware, but with different vendors, do you get different options and different configurations, really. So any questions? Well, let me draw your attention to this. So we looked briefly last time at computerscience1.net. We've been adding additional content to this. And at the left-hand side, you'll always see the menu, alphabetically ordered. You'll see not only the lectures materials, including the videos, which you might be watching right now, any PDFs thereof, and also the course's assignments. So per the syllabus, assignments are generally assigned weekly. And here's what to expect. We mentioned this very briefly last week. Generally, on weeks where homework is assigned, it will be part an opportunity to explore in greater depth one or more topics, ideally of interest to you, whereby we'll provide a list. In this case, I'll pull up the current one, a list of germane topics to the most recent weeks. In this case, we have a whole list of terms: AGP, ASCII, ATA, bank, base 2, base 10, BIOS, Blu-ray, bus, CD-ROM, some of which we might have touched on, some of which we might have really touched on, some of which we might not have touched on, just because they didn't come up in conversation or they just weren't worth spending a lot of time on, but they're still worthy of exploration on the side. And one of the challenges with each homework will be to write your own article. Paragraph, 2 paragraphs, this is not an essay, on that particular topic. And we'll provide you with links in the homework to resources for learning about this stuff. Wikipedia is not bad, but at least in the computer world, it tends to be a little too technical for its own good, at least for someone who's learning the material. So Webopedia is another one that we'll tend to link to. And frankly, Google, Bing, whatever you like to use is the best starting point. And the idea here is, and you'll see in the homework assignment, we're very detailed as to what to do, how to do it, and what the expectations are. But it's really an opportunity to take a topic that seems a little interesting, or you have no idea what it is, why not use this as an excuse to learn, and to go and write in sort of layman's terms an article that explains to your classmates and to anyone else who might browse the article what that technology is. And we've provided you with a sample article written by us on motherboards, for instance, just to give you a sense of the tone and the amount of technical rigor. But again, we're not looking for you to impress us with all these acronyms and numbers. It's really meant to be written for a person just like you, or a family member that you want to kind of have a normal conversation with, but still elevate their technical understanding of some topic. And then the other, so that we're actually keeping abreast of current events and actually engaging in interesting conversations, you'll see that the course also has the E1 blog. So blog, as we'll discuss briefly in our internet lectures, is just a frankly silly word to describe a website that someone or someones are constantly posting new content to. Generally articles, generally posts written in the first person, singular or plural. You're probably familiar with at least the notion these days of a blog, and if not, no worries, we're going to make one collectively. So the idea here too with most assignments is that you'll be challenged each week or 2 weeks to just keep an eye out, whether it's in the printed media, New York Times, or whatever you subscribe to, or online. We point you to a number of popular tech sites and blogs for just something that's interesting. Maybe it's CNN.com, maybe it's Google News or the like, but there's something technical out there that maybe a month or two ago you might have scratched your head and not really known what was going on, but this time you notice one word that's perhaps finally a bit more familiar to you. And even if you don't understand the whole article, the goal will be to read it over, just take a passing interest in it, and then write about it on the blog. Post the link, post the title thereof, and just strike up a conversation, a few sentences, maybe a paragraph or two with your classmates about what you read, how it might be germane to the course. And it's an opportunity then for your classmates to, one, stay abreast of the same kinds of things that you found, learn a bit more about what you've pointed them toward, and generally just get broader exposure than you yourself might get by just looking around sort of in a vacuum at various tech articles. So you'll find this is a nice way, ideally, to engage with classmates if you so choose by way of the comments and the like. And so what you'll see in the homework ultimately for this week that appears on computerscience1.net is we're going to ask you to get one, what's called an FAS account, Faculty of Arts and Sciences account. This is just a username and password with which you can start to log into the course's website. That process can take a couple days to get active, so I would at least do that ASAP, next couple of days. But you do have 2 weeks for the assignment. You'll see that we'll generally offer these sliding scales, and the 2 main components are then the blog and the wiki, as it's called, an editable website for this first week. But next week, we have just fun and food, a movie night with Pirates of Silicon Valley. Do bring friends or dates, and we will see you next week. Oh, yes, I would be remiss if I didn't say that. Also, there is, in fact, sections after class. We scheduled them right after class so that you can minimize the number of commutes to campus. They'll be led by our extraordinary teaching fellow, Rose Cow, here. It's going to be right across the hallway, so just follow Rose here in the green shirt if you'd like to stick around. They will be filmed, so if you can't stick around physically, rest assured the video will appear online within a few days. So do join us tonight if you can across the hall with Rose.